everyone, welcome to Xiao Hei Classroom. In this section, we will introduce the use of A6 Servo position mode. We mainly introduce from these aspects, first a brief introduction to the location mode, and then we will introduce the communication location and external location mode respectively, including hardware connection and parameter configuration, and then programming in the host computer software. Let's first look at the concept of location patterns. The positioning control mode is the most important and commonly used control mode of the servo system, which is widely used in the situations requiring positioning, such as printing, packaging, textiles, and other industries. The positioning mode usually refers to controlling the position of the motor by the positioning command, determining the target position of the motor by the number of positioning command pulses, and the rotation speed of the motor by the frequency of the positioning command. The servo system can quickly and accurately control the position and speed of the machine. Compared with the stepping system, it has the characteristics of high control accuracy, fast speed, and strong load capacity. There are two modes of position control: communication position mode, change the position command, through communication mode for position control. External position mode, control the rotating position and speed of the motor through the number and frequency of external pulse input, and control the position. Then here is the control block diagram of the servo system. When we perform position control, we give the position command. After being controlled by the position loop, we move according to the position we give, and the position signal can be formed into a closed loop control. Just now we talked about the position mode. There are two types of communication and external position modes on the general category. Then we look at the figure on the right. First, you can use the parameter P to 0.002 to set it to 1 to select the position control mode. After selecting the control mode, you can select the source of the position command through P3.000. On the premise that P3.000 is set to 0, when P3.002 is set to 1, it is controlled by external pulses, and then select the high-speed pulse input type through P8.000. If P3.002 is set to 2 or 3, it is multi-segment position command control. And then multi-segment position command control is divided into two types. One requires a start signal, and the other does not require a start signal. In addition, you can choose whether it is a relative position or an absolute position through bit 6 of P to 0.030. And then you can also set the default position command type after the servo is powered on through bit 2 of P to 0.009. Like the start signal of multi-segment position control, it can be given by bit 9 of P2, 31, or by configuring the determinal with function no, 26. The selection of multi-segment position instructions can be configured by bit 4 to bit 7 of P to 0.031, or by configuring the determinal with function no to 1 to 4. So let's first introduce the use of communication location mode. The parameters related to the communication location mode are listed here. If you use this mode to communicate, you can set the parameters according to this table. Multi-section operation can be selected through determinal. You can also select multi-stage. Then you can select the source of the position command by selecting 1 to 4 as 0, or 1 through multiple instructions. With determinal control, in addition to configuring the function to the corresponding determinal, it is also necessary to select the effective logic level for each terminal. Here is the diagram of the servo and host computer software MagicWorks tuner, connecting through the Modbus serial port, and the servo hardware interface is RJ45. Here is the definition diagram of the RJ45 port pin. You can follow this diagram to make a cable. Then let's take a look at the programming in the host computer software. Take this Modbus RTU communication as an example to introduce. Use the CTH200 series PLC to control the A6 servo through the Modbus RTU to realize the function of positioning and returning to the original. Use Modbus RTU to control the servo and support the following function codes, such as function code hexadecimal 03 to read single or multiple drive parameter registers, 6 to write single drive registers, and 10 to write multiple drive parameter registers. Then, in addition to knowing the corresponding function code, we also need to know the Modbus address corresponding to the servo parameter address. The following formula can convert the servo parameter address to the Modbus address. For example, the parameter P3.002, the servo group number is 3, and the parameter number is 2. After entering the formula below, it is converted to the Modbus address. It is 3 times 256. Then add 2 and add 40,001. Finally, it is equal to 40,771. Then there is also a need for hardware connection here. If there is an origin switch or limit signal, etc., it is through the DI terminal of the corresponding servo. For example, an origin switch is connected on the left here, and then it is connected to DI2. A forward travel limit is matched on the right, and then it is connected to DI1. Then connect it according to the corresponding wiring. After the hardware is connected, follow the steps below to configure the parameters. Next, you can use the Modbus to master library to program in the PLC to control the reading and writing of servo parameters. Multiple read and write blocks need to be pulled and triggered. For parameters that only need to be set once, they can be written directly through the panel. There are 2 Modbus to master libraries. You need to select the correct library instructions according to the port of the PLC you use. Then the library contains 2 instructions. Through this Modbus_CTRLL, the master station can be initialized, and parameters such as baud rate and verification of communication can be set. The next instruction is the polling trigger for parameter reading and writing, which realizes the reading and writing of servo parameters. Here, the parameter address has been converted to the corresponding Modbus address. These 2 write operations enable the servo and return to the original, respectively. Then, after returning to the original, the servo positioning operation is realized by writing the parameter given position to the position command. Let's look again at the use of the external position pattern. The parameters that need to be used in the external location mode are listed here, and the parameters can be configured according to this table. This is the definition diagram of the pin of the servo external terminal. When using the external position mode, the pulse, direction, and other pins need to be connected according to the pins shown in the picture. Then here correspond to the specific wiring diagrams of the host computer output type PNP and NPN output type respectively. This is the wiring diagram for the differential output type. Let's see how we can control the servo by sending pulses in the software. Here, the M226CS is used to control the servo operation by sending pulses. For parameter settings, please refer to the settings here. M226ES is the NPN output type, just connected according to the wiring shown. Taking the return to the original mode 17 as an example, here is the return to the original track diagram of the mode 17. The M226ES needs to configure the axis configuration in the hardware configuration and configure the pulse and direction output points. On the conversion interface, the shaft dimensional conversion parameters can be set. The first behavior motor needs how many pulses to rotate one turn, which needs to match the electronic gear ratio. Configuration of the servo, the second behavior gear reducers reduction ratio, and the third behavior gear outputs the distance of one turn of actual mechanical motion. The unit is the application unit. The speed of the motor can be limited on the speed interface. You can set hard and soft limits on the restriction interface. If the return mode involves limits, you can set positive and negative limits here. On the return to the original interface, you can configure the return to the original mode, as well as the return to the original speed and acceleration. The unit is pulse. After completing the hardware configuration, we need to call the PLC Open Library instruction in the PU to control the axis. Here, enable, absolute positioning, and return to the original instructions are called, which can realize the enable, absolute positioning, and return to the original operation of the axis. Note that the unit on the absolute positioning instruction is the application unit, not the pulse. The meaning of the instruction can be found in the manual. This is the DIP-PIN configuration table, which DIP-PIN configuration function needs to be given. Write the value of the corresponding function to the parameter address, corresponding to the corresponding DIP. Then here is the configuration table of the do pin. Which function you need can directly write the value of the corresponding function to the parameter address corresponding to the do. Here are the wiring diagrams of the digital input and digital output circuits. The input supports NPN and PNP types, and the output only supports NPN types. That's all. Thanks for watching.